Here we're going to look at a couple different examples of trying to solve logarithmic equations, and we're going to use all of our log properties and exponential properties we have at our disposal in order to do that. So first things first, when looking at any equation, the first thing you want to be glancing for is what kind of properties do we have that can be used. And right away when you look at this equation, you can see that I've got this plus sign here, which can condense through the product rule. So the product rule essentially says I'm going to take it from 2 logs down to 1. So I have log base 4, and it's going to be x minus 3 times 2 equals 3. Now here I have a log only on one side. So I want to use a very specific rule. And so the rule that I'm going to use, or the property I'm going to use, simply says that if I take a to the log base a of x, I get x as a result. So what you can notice here is that if I use an exponential base that's the same as the base for my log and apply this rule, then whatever was my x value comes out. So here, notice my base right here is a 4. So I'm going to then take and raise both sides as a base of 4. So this then becomes the log base 4 of 2 times x minus 3. And this is going to equal a base of 4 raised to the third. So what you have to remember is whatever you do to one side, you got to do to the other. So here, my log base 4, so this piece right here, this is going to undo each other. And it's going to leave behind the extra stuff. So here we're going to end up having that we are going to solve 2 times x minus 3 is equal to 4 to the third. So here 4 to the third is 64. So here we're going to have 2 to the x minus 3 equals 64. So with that, we can solve for x. We're going to divide everything by 2. So we have 64 divided by 2. So x minus 3 is equal to 32. So x is going to give you 35 as a result. Okay? Alright, let's take a look at this next example here. So here I have e to the 2 natural log of x, and then I have 4 log of 10. So there's a couple things that can occur here. First, this 2 is actually a power. Second, the log of 10, this undoes each other. Because this is a common log, which means it is base 10. So since this is base 10, the log base 10 of 10 becomes 1. So here what we're really left with is e to the natural log of x squared is equal to 4. Now with that, we have e to the natural log. Well, this piece right here also is going to undo each other. With that, it leaves us with x squared is equal to 4. Take the square root of both sides, and I have that x is equal to 2. Alright, let's look at this bottom one down here. So again, I have to look at what is it that I have. So the first thing I see right off the bat is I have a power rule. And so this is going to become the natural log of x plus 3 squared equals the natural log of 12x. So in this case, I can take each side and I can raise e to them. And so here I'm going to have e to the natural log of x plus 3 squared equals e to the natural log of 12x. Again, this e to the natural log is appearing on both sides, so that is going to go away, and it's going to leave me with x plus 3 squared equals a 12x. Now, the thing that I have to do here is, if I look at my square term, I have to do the math, which in this case means I have to FOIL. So I'm going to FOIL this out, so I'm going to end up with x squared plus a 6x plus a 9 is equal to 12x. I need to move the 12 over, so I end up with x squared minus a 6x plus 9 equals 0. So this here is going to give me x minus 3 and x minus 3, which equals 0. Instead of trying to solve twice, I can just simply solve once. That in this case, x is equal to 3. Alright, the last one that I want to look at is this one here. So first and foremost, notice my bases are the same, and when I look at this, the first thing I see is that I have a quotient rule. So the quotient rule says that I have to subtract. So this is going to become the log base 3 of x plus 1 over x minus 4. And this whole thing equals a 2. Now, just like before, I have a single log on one side, so I'm going to look at its base and I'm going to apply that rule. So I am going to rewrite using a to the log base a of x rule. So here this is going to become 3 to the log base 3 of x plus 1 over x minus 4, and that whole thing is going to equal 3 raised to the second power. Now with that, this piece right here is going to go away, and it's going to leave behind just my rational. So I have x plus 1 over x minus 4 is equal to 9. Okay, and that's because on this side we need to do the math. Now with that, I have to solve. So I'm not quite done because I have to be able to get x by itself. So I'm going to multiply this entire thing by the x minus 4. And what's going to happen is that's going to give me x plus 1 is equal to 9 times x minus 4. My goal is to get my x's by itself, so I'm going to continue to solve. X plus 1 is equal to a 9x minus 36. I want to get my x's by itself, so here 37 is going to be equal to 8x. In this case, 37 over 8 is going to give me x. Since there's nothing else to do to simplify, there we go. So there you have it. Quite a few examples on being able to solve logarithmic equations using both log and exponential properties to get that solution down by itself. So if you have any questions, please let me know. Otherwise, I hope you enjoyed this video and that it made you smile, and I'll see you next time.